Hello, this lesson is going to be on multiplicity of zeros. The word multiplicity just means how many times something happens. So a multiplicity of zeros is how many times a zero happens. So let's start with what what is a zero? First of all, remember that if this function has a factor of x minus some a naught, so this is x minus a naught times g of x, then a naught is a zero of f of x. Why is this true? Well, what that's saying is that f a naught will be a naught minus a naught times g of a naught. So I just substituted a naught in for x, and then I'm going to get 0 times g of a naught. So it's not going to matter what the rest of the function is. All of the 0 times whatever will give us 0. So that means that as soon as some factor appears, x minus a naught, then a naught has to be a factor. A naught has to be a root. So what we say is, what if something appears more than once? What if the factor appears more than once? So if we have x minus 12 squared, then we would say 12 has a multiplicity of 2, because really what's happening is this root of 12 appears once in the first set of parentheses, and then this is x minus 12 times x minus 12. The second one also counts. So multiplicity, the frequency, so how many times a number is a zero in a single function. So let's find the zeros and multiplicities for each of these functions. Here we have 3 is the 0 here, with multiplicity 2. Here we have, let's see, x plus 7 means negative 7, with a multiplicity of 1 because there's no exponent. That's the same thing as raising it to the first power. And negative 10 has a multiplicity of, based on that exponent, 4. Simple enough. Here, the coefficient doesn't matter. We'll just say that negative 1 has a multiplicity of 3. And it's not 5 has a multiplicity of 2. 2x plus 5, what number solves this would make 2x plus 5 equal to 0? Well, negative 5 halves. If you plug in negative 5 halves, or if you solve 2x plus 5 equals 0, you'll get negative 5 halves. So that is our root for the second set of parentheses, and that has a multiplicity of 2. What about here? Well, 0 has a multiplicity of 3 because of the x cubed. That's x minus 0 cubed. And then over here we have something that can be factored. So this is the same thing as saying, what is this? This can be factored as 9x squared plus 3x plus 3x plus 1. So this is the same thing as 3x plus 1 squared, and that's then being raised to the 4th power. So that's the same thing as 3x plus 1 to the 8th power. Hopefully you agree that if we factor this, we get 3x plus 1 squared. So that's 3x plus 1 to the 8th power, including that 4th power. So this is a root of negative 1/3, because 3x plus 1 equaling 0 would give us a root of negative 1/3. And the multiplicity of that root is 8 because of the exponent. The last thing to note is that this idea, not just how to find it, but it means something in terms of a graph. When a 0 has an odd multiplicity, just like if it only appears once, it crosses the x-axis. But when a 0 has even multiplicity, it bounces off the x-axis. The most straightforward example is if I have a line versus I have a parabola. Here, this is a root that appears twice. Parabolas have two roots. If this root is just one root, then it means that it has a multiplicity of 2. Whereas a linear equation only has one root. And this one crosses the x-axis, this one bounces off the x-axis. But no, even if we make it more complicated, here's a function where I'm changing the multiplicity of each of these roots. So this slider changes the multiplicity of this root of negative 6 comma 0. The second slider changes the multiplicity of negative 1 comma 0. And then the third slider changes the multiplicity of 3 comma 0. So if I change the multiplicity of the first 0 to be 2, now it's bouncing off here. It's bouncing off here, but it's still crossing at the other two. Once I switch it back up to an odd number, 3, then it's flattening out, but still going across before crossing and crossing again. Now we've made it even again, so an even multiplicity. So it's bouncing and then crossing and then crossing. What about if we change the second one? If I make the second one even, if I make it a multiplicity of 2, now it's bouncing and bouncing and then crossing because this one still has an odd multiplicity. If I increase this to 3, well, it'll still cross because it has an odd multiplicity. But if I go back to a case where they all have even multiplicity, this is the negative 6 has a multiplicity of 4, this has a multiplicity of 2, this has a multiplicity of 2, then each time it's bouncing. So, to recap, when a 0 has odd multiplicity, like this one, it crosses the x-axis. But when a 0 has even multiplicity, it bounces off the axis. So right here and here. That's multiplicity.